Here is our lesson topic and outline. Global COVID-19 data analysis and visualizations. In this lesson, we will explore global COVID-19 data. You will learn how to analyze and visualize trends over time. Data mining can help you spot important patterns in real-world health data. Visualizations turn raw numbers into insights anyone can understand. By the end, you will have skills to do your own data exploration projects. This lesson is beginner-friendly with clear, simple steps. Running the cell now. Let us explain what data mining means for COVID-19 data. What is COVID-19 data mining? Data mining means finding patterns in large data collections. COVID-19 datasets record infections, recoveries, and deaths worldwide. With the right tools, you can visualize outbreaks, trends, and risks. This helps scientists, leaders, and the public understand what is happening. We use Python because it is powerful yet beginner-friendly. Running the cell now. Let us begin by making sure annoying warnings will not pop up. We are turning off warnings to keep the output clean for learning. Import warnings, warnings.filter warnings, ignore. Import numpy as np. We set the random seed to 42 for reproducibility. Running the cell now. This code sets up a smooth and reproducible environment by suppressing warnings and fixing the random seed. Although it produces no visible output, this step ensures that your COVID-19 data mining runs without distracting messages and that any random processes produce consistent results each time you run the code. This preparation is essential before diving into analyzing and visualizing the complex COVID-19 datasets. This lets us focus on exploring data, not on technical alerts. Now we will load the global COVID-19 confirmed cases dataset. You only need an internet connection for this step. We start the data setup section with a comment. We import the pandas library. We specify the Johns Hopkins CSSE Global Confirmed Cases Time Series URL. We read the CSV from the URL into a data frame. We print the shape of the data frame to see its dimensions. We print the first 3 rows of the data frame to preview the data. Running the cell now. This output shows the shape and a preview of the global COVID-19 confirmed cases dataset, with 289 rows, locations, and 1147 columns, including dates and geographic info. Notice the first few columns identify regions, while each subsequent column tracks cumulative cases by date, illustrating how the data is structured for mining trends over time. This setup is key for exploring infection patterns across countries and dates using Python. This gives you a table where each row is a country or region. Columns show daily confirmed case counts for each date. Let us describe what we just loaded. A quick look at the data. Each row is a country or region. The first columns hold country and location details. The remaining columns give confirmed case numbers for each day. Our goal is to analyze how cases changed over time and across places. Running the cell now. Next, let us check the information about the loaded table. We are checking how many rows and columns the data has. The info function also shows column types. Running the cell now. This output summarizes the dataset structure, showing 289 rows, each representing a country or region, and 1,147 columns, with the first few holding location info and the rest daily confirmed case counts. Notice that most columns are numeric, reflecting case numbers over time, which aligns with our goal of tracking how cases have evolved across places. This quick overview confirms the dataset size and data type suitability for time series analysis. This lets us see if anything is missing or unusual before exploring further. It is good practice to check for missing values early on. We check if there are any missing values in the first few columns. Print df.isnal.sum.head. Running the cell now. This output reveals where missing data exists in our dataset, notably, 198 missing entries in the province-state column and 2 missing values in both lat and long columns. Since the country, region and initial date column have no missing values, we can confidently rely on them for our time-based and geographic analyses. Identifying these gaps helps us plan how to handle incomplete data before exploring case trends across regions and dates. No missing values means our data is ready for analysis without extra cleaning. Let us explain what needs to be changed to study overall trends. Preparing data for analysis. To visualize trends, we need totals per day for the world. We will sum all countries for each date column. This creates a global time series to plot. Running the cell now. We will select the columns that hold daily case numbers. Then we add up all rows for each date to get the worldwide total. We are getting the global daily total confirmed cases. We select all the date columns starting from the 5th column onwards. We sum the values in those date columns across all countries to get global totals. We print the first few values of the global total cases. Running the cell now. This output shows the global total confirmed cases for the first 5 dates, obtained by summing cases across all countries for each day. Notice how the numbers increase daily, reflecting the growing spread of the disease worldwide. This step is essential for preparing a clean time series to visualize overall trends in the data. This gives a daily running total of confirmed cases across the whole world. Let us visualize the big picture by making a simple line chart. Line plots are great for tracking how numbers change over time. This comment explains that we will plot global COVID-19 cases over time. We import the Matplotlib library's PyPlot module to create plots. We create a new figure with a size of 10 by 5 inches for the plot. We plot the global total cases with dates on the x-axis and case numbers on the y-axis. We add a title to the plot to describe what it shows. We label the x-axis as date to indicate the timeline. We label the y-axis as total cases to show what is being measured. We rotate the x-axis date labels by 45 degrees to make them easier to read. We adjust the layout to ensure everything fits without overlap. We display the plot on the screen. Running the cell now. This plot shows the global total of confirmed COVID-19 cases over time, which we created by summing cases across all countries for each date. Notice the upward trend reflects the cumulative increase in cases worldwide, giving a clear view of how the pandemic evolved day by day. This visualization confirms that our data preparation successfully aggregated daily totals to reveal overall global patterns. You should see an upward trend showing how fast cases increased globally. Try changing the plot to see other trends later. Seeing numbers at the start and end helps compare early versus recent growth. This comment explains that we will display the first and last 10 days of the global total. We print a label indicating we are about to show the first 10 days. We print the first 10 rows of the global total data. We print a label indicating we are about to show the last 10 days with a blank line before it. We print the last 10 rows of the global total data. Running the cell now. This output shows the total global cases summed for each date, starting with the first 10 days of the outbreak and ending with the last 10 days in the dataset. Notice how the counts steadily increase, reflecting the growth over time, which confirms that summing across countries successfully created a comprehensive global time series for trend analysis. This step is crucial for preparing the data to visualize overall patterns in the pandemic's progression. Looking at the raw numbers lets you spot surges or slowdowns. Next, we will show how to focus on country-specific trends. Focusing on individual countries. Sometimes we want to zoom in on a single country. This helps compare trends between places like USA, India, or Italy. We will show how to select a specific country and plot its trend. Running the cell now. Let us try finding and plotting numbers for a specific country like India. You can do the same for any other country by changing the name. Pick a country to explore in the data. Here we choose India. Filter the data frame to keep only data for India. Sum the case numbers for each date to get total cases in India. Set the figure size for the plot. Plot the total cases over time using an orange line. Add a title to the plot to describe what it shows. Label the x-axis as dates. Label the y-axis as total cases. Rotate the date labels on x-axis for better readability. Adjust layout so labels and title fit well. Display the plot in the notebook. Running the cell now. This plot shows the total confirmed COVID-19 cases in India over time, with a clear upward trend as the pandemic progresses. By filtering the dataset to include only India and summing across all its regional data, the code highlights how cases accumulate day by day, illustrating the importance of focusing on individual countries to compare their unique outbreak patterns. Notice how the trend shape for India may differ from the global one. This allows you to compare outbreaks between countries. Now you try. Let us make the script ask for your favorite country. Just type a country name and it will show its trend. We use Python's input function so you can type in any country name. The code finds matching rows for only that country. We sum across regions to get one total time series. We make a new plot using your chosen country. The color is green for variety. Titles and labels are updated automatically by the code. We label the x-axis as date for clarity. We label the y-axis as total cases to show counts. We rotate dates for better readability. We adjust layout so nothing overlaps on the plot. Finally, we display the plot so you can see it. Running the cell now. This plot shows the total confirmed COVID-19 cases over time for the selected country, allowing us to focus on its unique trend. Notice how the shape and growth pattern reflect how the virus spread locally, which is easier to analyze when isolating one country's data. This targeted view helps compare different countries' trajectories more clearly. Try out different country names to compare their outbreak patterns. You can learn a lot by exploring real-world data hands-on. If you are enjoying the lesson, hit like and subscribe for more practical data tutorials. Let us see which countries have the highest number of cases up to the latest date. This is a comment explaining that we will compare the top 5 affected countries. We group the data by a country or region and sum the values for the most recent date column, then sort the sums in descending order and take the top 5. We print a message indicating that the top 5 countries by total confirmed cases will be shown. We print the resulting top 5 countries with their total confirmed cases. Running the cell now. Here, we identify the top 5 countries with the highest total confirmed cases as of March 9, 2023, highlighting the US and India at the top. Notice the clear ranking. This helps us decide which countries to focus on for detailed trend analysis. This selection sets the stage for zooming in on individual countries to compare their COVID-19 trajectories. This helps you quickly spot which countries need the most attention or resources. Let us make these rankings visual with a bar chart. This comment describes that the chart will show the top 5 countries. We import Seaborn to create attractive and informative statistical graphics. We set the figure size to make the chart appropriately sized. We plot a horizontal bar chart of the top 5 countries with total cases on the x-axis. We add a label to the x-axis to describe what the values represent. We add a label to the y-axis indicating it represents countries. We give the plot a title to explain its purpose. We adjust layout to fit everything nicely within the figure. We display the final bar chart on the screen. Running the cell now. This bar chart highlights the total confirmed COVID-19 cases for the top 5 countries, emphasizing how case counts vary across these key locations. Notice the clear ranking by case numbers on the x-axis, which sets the stage for comparing one country's trend in detail, helping us decide which country to zoom in on next. The intent is to identify major hotspots so we can analyze their individual trends closely in the following steps. You can now spot differences in national outbreaks at a glance. Let us dig deeper, not just totals, but changes from day to day. Discovering new daily cases. Total numbers are useful, but it helps to see day-by-day changes. New daily cases show how fast an outbreak is growing or shrinking. We can compute daily new cases by subtracting each day's total from the previous days. Running the cell now. Here is how to turn totals into new daily case counts. We take the difference between each day's total and the one before it. We fill any missing first value with 0 and turn results into integers. We print the first 10 days as an example. Running the cell now. This output shows the calculated new daily global cases by subtracting the total cases of each day from the previous day, highlighting how the outbreak changed day by day. Notice the initial zeros, followed by increasing daily cases that reflect the outbreak's acceleration, which is exactly what this code aims to reveal, helping us track the speed and trend of the disease spread rather than just cumulative totals. Looking at new daily case counts reveals spikes and waves that can warn of outbreaks. A bar chart is a good way to see how new cases change from day to day. This comment explains that the plot shows new global daily cases. We create a figure with a width of 10 inches and a height of 5 inches for better visibility. We plot a bar chart using the dates as the x-axis and new cases as the y-axis, coloring the bars blue for clarity. We set the title of the plot to describe what is being shown. We label the x-axis with date to indicate what the horizontal axis represents. We label the y-axis with new cases to indicate what the vertical axis represents. We rotate the x-axis labels by 45 degrees to improve readability. We adjust the layout so that everything fits well without overlapping. We display the plot on the screen. Running the cell now. This bar chart visualizes the daily new confirmed COVID-19 cases worldwide, highlighting the fluctuations in outbreak speed over time. Notice how the height of each bar represents new cases each day, allowing us to easily see peaks and declines rather than just cumulative totals. This aligns with our goal to track the outbreak's momentum day by day for better insight into its progression. Look for sharp peaks that may signal outbreaks or slowdowns after interventions. Let us wrap up what you learned today. Summary and next steps. We loaded and inspected a real COVID-19 dataset. We visualized global and country-specific trends. We saw how to compare nations and spot changes over time. There is much more to explore. Data mining opens many doors. Try changing the country, plotting different time windows, or exploring deaths and recoveries. To keep learning, please subscribe and check out other lessons on this channel. Practice makes perfect. Keep experimenting with your own questions. Running the cell now. Thank you for joining in. You are now ready to analyze new datasets with Python. See you next time.